Before lunch, we were talking about the disinfection byproduct rules. What I'm going to talk about now is the disinfection byproduct sampling. You're going to find out that a lot of this stuff is very repetitive. It sounds very similar to some of the stuff we talked about this morning, but there's slight variations. You'll find that the collection of the samples for the disinfection byproducts follows almost the same procedure as the back T samples. We already talked about what the disinfection byproducts are. The trihalomethanes, the haloacetic acids. You got your limits up there. Now, in order to decide where you're going to collect your samples, it's much like your back T samples. You have to have a plan. You can't just randomly say, I'm going to throw a dart at the map today and see where I want to go, or I'm going to go find that restaurant I like to eat at and I'm going to go collect my sample there. You actually have to have a plan. It's got to be representative of your system. If you're interested in taking a nap, you can go to the Code of Federal Regulations and read all about it. You'll probably make about a page into it, take a nap, wake up, read another page, take another nap. Now, one key factor you do need to make sure you remember, the samples have to be collected in your distribution system. Any idea why? Who said time? You want to elaborate on that a little bit? Exactly. The disinfection byproducts are, as we said, formed when there's a contact between the free chlorine and your organics. Well, it takes time to form that. It's not an instantaneous reaction. Well, you want to find out if it's forming once that water sits out in the system, because once it leaves your plant, that water may sit in your distribution system longer than it ever sat inside your plant. And it's not one of these situations where we don't want to know what's going on. Obviously, we don't want to find disinfection byproducts, but if they're there, we do want to know they're there. All right, now this was written based off of a national standard, a national average general practice. I've been told by a couple of people here that the particular labs you use don't use this setup for the bottles. But normally you have 5 bottles in a disinfection byproduct sample. 2 40 milliliters bottles, 2 2-milliliter vials, and then a 250 milliliter bottle. Now, I understand some places here, you actually only collect one large sample and then the lab divides it up. Is that? Mm-hmm. All the same size. Do you know what size approximately? Okay. So basically, they're probably just having, now this was 6, you collected all in one location? Okay, that's a new one. Okay, so they're having you collect 3 bottles per point then. Okay. Are you sure this wasn't lead and copper samples? That sounds like a lead and copper setup. Okay. Well, again, this is something that will be dictated by the lab you use, and it can vary from. Okay. So it's probably a state standard then. Like I said, because actually these samples, they don't take all these different, they don't take all these amounts. What it is, they actually have to make sure they have enough in case they have to run it over. Like if the sample's inconclusive, something happens to the bottle. So they're going to want you to have multiples. Like we had one person Tuesday said that they just collect one big sample and send to the lab. Well, the drawback with that is, what happens if that bottle gets cracked, it leaks, because we know that shippers take utmost care of all our samples. They don't throw them, drop them, use them as a step stool or anything like that. If you have multiple bottles in there, the chance of at least one good sample getting to the lab is a lot better. Well, one thing I forgot to mention there, just like with your back T samples, you had the sodium thiosulfate in your bags. In these bottles, there's a preservative also. It's slightly different. It's not thiosulfate, it's ascorbic acid, but it's basically doing the same thing. It's preserving that sample, trying to get an accurate representation of what was in that water when you took it. just like with your back T samples, they're subject to contamination. So what you want to do, you want to make sure you've got a good, accurate sample tap. Something that truly represents what's in your system. You know, you want, if you're collecting in a business, which we've been told multiple times, Louisiana doesn't allow you to collect samples inside a residence or, well, I guess if you work for the business, you can collect inside. But if you are collecting inside, look for a sink or a tap that doesn't have a strainer on it, you know, has that doesn't have a single handle, you know, anything that could potentially throw that sample off, give you a false positive, you know, because you want to find it if there is something there, but you don't want to have to report that you've got a problem if you really don't. You know, in order to make sure that you're getting an accurate representation of what's in the distribution system, particularly if you are sampling inside the building, you want to make sure you turn that tap on, let it run for a few minutes. You got to remember, you might have 100 feet of service lead from out there at the main, or if you have a really big complex, you may have a lot more than 100 feet. You know, you don't want that water that's just been sitting in that service line, sitting inside that plumbing in the building. You want to find out what's in the distribution system, what's actually coming from, you know, your source of water. So give it at least 2 to 3 minutes. One thing you can do, put a thermometer in there, something to measure the temperature, because you should see a noticeable change in the temperature once you get the water that's coming from the mains. You know, then you follow the same procedure you would for a back T sample. Reduce it down to a pencil-sized stream, fill your bottle up to the designated mark, which on this is not like the back T samples where they have a line. Like I said, your bags, how many ounces does the Whirly Pack bags hold? 4 ounces? How many ounces do they actually need? But it gives you room for more than what they actually need to run the test. Now on your disinfection byproduct samples, it's very important. Fill the bottle all the way to the top. There cannot be any kind of air in that bottle because disinfection byproducts, they're volatile. They react with the air. By having any air in that bottle, you can dramatically change your results. So, now what we've heard as a rule of thumb here is less than the width of a dime worth of airspace in there. But really you should be trying to get it to 0 or as close to 0 as possible. What I tell my collectors, the guys who collect my samples, fill that bottle up till you see a meniscus, you see that little curve of water on top. Take your cap, fill it full of water. Bring them together, should eliminate almost all your air. Now, once you do that, to make sure that you have gotten all the air out, shake that sample up, turn it upside down, look for air bubbles. Because if you've got it all the way full, you're not going to see any air bubbles. You know, there's no room for that water to mix around. And just like with the back teas, you know, don't let your jar touch the sample tap. Don't put your finger in there because again, no telling what you've touched. You know, you could have handled anything that could potentially put a contaminant in there. Like I said, this is based off of this type of sample jar, but follow the procedure for filling up whatever sample jars your lab sends you. You know, don't tell them, hey, we went to a class and they said we're supposed to have 2 40 milliliters, 2 milliliters, and 1 250. Whatever your lab gives you, just follow and fill them all up. Biggest thing, just make sure you got them full, no air in them. You know, once you do that, you know, your shake test, you flip it upside down, you look for air bubbles. If you see any, go ahead and top it off then. You know, don't say, well, it's close enough. You know, I'll take the lab, because you know what's going to happen? You're going to get to the lab, or you're going to ship it off to the lab. They're going to look at it and say, it's got air in it. I can't accept these. Now what have you done? You just wasted your time. You've wasted the money. You've wasted shipping. And you're going to be right back out there collecting again. So take that extra minute, you know, double check your stuff before you put it in that box. Also, probably one of the most frustrating things you can do, collect all them samples, pack everything up, you check it, no air, everything's good, you drop it in that box, you forgot to snug down the top. Make sure you snug that top down. Don't over tighten it where you're gonna break the seal or anything, but just make sure it's nice and snug, that way it doesn't start leaking. especially if you're shipping. You know, if you're hand delivering it to the lab, it's probably not as big of a deal because, you know, you're handling it. You know how the package is being handled. But when you get that stuff in a shipper, FedEx, UPS, whoever, you know, that box could be thrown around with them bottles. You know, you want to make sure they're nice and tight. We already talked about that. Also, like I said, you got 6 sample bottles from your lab. Now, did they give you instructions on how many to collect from each one? Okay, that's important. Follow their instructions, because just because they send you 6 bottles doesn't mean they want 6 samples from different locations. A disinfection byproduct sample, if it's multiple jars, it's generally from one point. You know, you can't say, well, I'm going to fill up half from this sink and I'll go over here and fill up half from this sink. That way, in case either one of them is bad, I'll get at least one good sample. Whatever whatever your lab tells you as far as how many samples to get, fill them all up at the same time from one location. You know, because it gives you 2 bottles, like this particular setup gives you 2 bottles. Don't fill one up in the morning, then come back that afternoon and take another bottle. Fill them up one right after the other from the same location. Make sure you label everything. Because again, if you get it in there, you spend all that time collecting it, you ship it, you forget to label it, or you use a non-waterproof marker to label it, by the time it gets there, you're shipping it, the ice pack starts sweating, they go to grab that bottle out of there, smears the ink. Well, if they can't identify where the sample was collected, you might as well not have even collected it. I said, just like with the BACT samples, they have to be refrigerated. You know. Now, if you are shipping them, or even if you're just carrying them in the cooler directly to a lab, you're better to use ice packs instead of just ice. If you don't have ice packs, buy you a pack of Ziploc bags, some freezer bags. Put the ice inside those, double bag it. That way you don't have your sample sitting there swimming in a pool of melted ice water. And make sure you get to know your lab, find out what their schedule is. Most places say no samples after 4 o'clock on Fridays. That way it gives them time to make sure they run the samples. But check with your particular lab, because some labs may have, you know, short hours. They may only work 4 days a week. They may work 7 days a week. Find out what hours your lab works and when they want the samples, because even if they work up to 5 o'clock, you don't want to get on the lab technician's bad side by getting them the samples every time at 4:59 on Friday, so he's got to stay there and set them up. And you also, some people say, well, if I'm going to ship them to make sure that they stay cold, I'll freeze them. The disinfection byproduct samples cannot be frozen. Whenever you package your stuff up, we all know you got to put a chain of custody form, something in there saying where those samples were collected, who they were collected by. Well, again, you're in a box full of ice, you got samples, something could leak. Make sure you protect that chain of custody form. Put it inside a plastic bag, something to protect it, so when it gets there, it's not damaged. Make sure that it's legible and they can use it. Because again, if you have those samples, you can have all your samples right, everything labeled good, they don't have a chain of custody or it's unreadable, they're going to reject your samples. Any questions, comments, concerns? See, I think that baby just spent all day collecting samples and forgot to label one of them. And I know we just ate lunch, so if you start feeling like you're gonna nod off or you need to get up and stretch your legs, feel free. You're not gonna bother me. What we're gonna talk about next is the distribution system. Do most of y'all work inside the plant, or you do a combination, work inside and outside the fence? Combination? I figure in your smaller systems, and I work for the city of Houston by day, so I'm used to, I consider a system with 100,000 customers, to me it's still a small system. So, but for most of your systems, I imagine your operators have to be more versatile. They have to do, we're so big, we have to specialize. We have people, their entire job is to do dead end flushing. In fact, it's an entire group. That's all they do. We've got people dedicated just for sample collection. In fact, different people dedicated just for certain kinds of samples. We have about 600 back T samples every month. That's just the back T samples. I think our lab process is somewhere in the 2,000–3,000 samples a month range. No, we have our own certified lab. That's it. In fact, we actually have 2 labs, and that's just for the water side. We have, wastewater has their own lab too. So I apologize if I use a bunch of City of Houston references or Texas references, but that's where I've worked all my career. That's what I know the best, so I'll reach back to there for examples and references. In fact, I'll go ahead and let y'all get a free shot. Anybody got a good A&M joke? As long as it's clean. Remember, we got a camera rolling. And no, that's a low blow. And no, Johnny Manziel wasn't able to make it because we couldn't afford to give him $7,500 to show up and sign autographs. All right, after completion of this section, you should be able to describe the common methods and devices used in the distribution of the water. When we talk about distribution, that's basically everything once you get outside the fence. Well, I take that back. We will talk some about inside the fence, but basically after the water's treated, what do you do once you get the water treated and get it out into the system? In fact, I understand y'all separate your license into production and treatment and distribution. Now, what's the difference between production and treatment? So basically it's a surface water versus groundwater. Okay, we call our surface water groundwater. So if you're pulling it out of the ground, you just call it production, and if it's surface water, it's treatment. So for surface water, you have to have both. But for groundwater, you can have just production. Okay. Yeah, y'all just try. I think y'all just trying to be difficult. We have groundwater, surface water distribution, and we have 4 levels of license. Our lowest level license covers everything because it assumes you're working under somebody, and our highest license, it covers everything because it assumes at that point you should be able to do everything. It's just those 2 mid-level licenses that we distinguish. But hey, as one of y'all told us earlier, Louisiana wants to set the standard for the world. But we'll give y'all credit. We'll say we're following you. We're going to talk about some of the different types of storage, major components of the system. talk a little bit about some of the aspects of pumps, their usage, selection, things like that. And then talk very, very briefly about motors. Now, once you produce this water, or treat it, or both, what do you got to do with it? You got to store it somewhere, right? Why don't we just pump the water right out of the ground, treat it, and send it straight on to the customers? Yeah, because most of your pumps and stuff, like let's take your well. You know, it's either on or off. You can't throttle it, can you? Yes, you could throttle it by choking back a valve, but it's not good to do that. But it's pretty much an on or off thing. Can you control when your customers turn water off and on? You know. Now, can your well keep up with if all your customers decide they want to take a shower at the same time? No, it gives you a chance to equalize. You know, you produce all the water you can. That way, whenever the demand is there, when people start wanting the water, it's available. You're not trying to play catch up at that point. You know, you fill your tanks up when the demand's low. Like I said, from my personal experience, that's generally at night for us. I understand a lot of if you work in an industrial situation, you know, you may not have a low demand, or it may be at an odd hour because you fill up your tanks. You know, you might fill your cooling towers at night or whatever the case may be. Find out when your low demand period is and try to be filling your tanks during that time. That way, when the demand does pick up, you've got all the water you need to meet that demand. Start sucking those tanks back down. Now, when I say fill at night and drain during the day, it's not an on or off situation. You could be filling while you're drawing out at the same time. Allows you to have uniform pumping rates. You're not trying to kick on that well and shoot it into the back of a pump. You know, one of your biggest times where you're going to have that emergency demand is if you have a fire. Everybody here have combined fire and domestic systems? Did have one guy yesterday said that they have, where he works, they actually have a separate system. So in that case, it might be a little bit different, but generally, you know, you have a combined system, that's when you're going to use the most water, because how much water does a 4-inch fire hydrant put out? Depending on the type of hydrant, you know, the particular manufacturer, the pressure, you could put out 2,000, 2,500 gallons a minute. I don't know about you, but we have some pretty big wells in Houston. Most of our wells don't put out 2,500 gallons a minute. Now, even if we do have a well that puts out 2,500 gallons a minute, what happens when they have to open up that second fire hydrant because the first one's not supplying enough water? Without these tanks, somebody's house is going to burn down, you're going to be on the news, or at least your mayor's going to be on the news, and then he's going to be calling somebody down to his office wanting to know what happened. You know, we have plenty of reservoirs, but we still have that issue. We have a particular area where there's low pressure or something, there's a big fire. First thing they want to know is, why didn't we have more pressure in that area? Sometimes we have a good answer, sometimes we don't. Also, it allows that contact time. We talked about it earlier when you're disinfecting your sample points. Chlorine's not an instantaneous reaction. It's not like, you know, it's not a magic wand. You can tap the water and it's clean. You know, it takes some contact time. Having that reservoir gives you that time. Usually the way it goes, when it rings in the middle of something, it's stuck in your pocket where you can't get to it. Now, sometimes for your ground storage tanks, depending on the situation, you'll hear them called different things. Sometimes you might hear them called a clear well. Generally, a clear well just means a ground storage tank inside a surface plant. Why they want to be different, I don't know, but that's the way it usually is. Most surface plants will refer to them as their clear well. If it's a groundwater plant, anything like that, it's a storage tank, ground storage tank, or just the tank. You can ignore that. That's TCEQ is our version of the DHH. It's our state agency that regulates it. We're going to talk a little bit about the requirements. I won't swear that they're the exact same for Louisiana, but all these standards, most of your state agencies go to the EPA for their guidance or AWWA for their guidance. So they're generally pretty consistent across states. You might see a slight variation. If you see something up here that you know isn't correct for Louisiana, let me know, point it out. Any opening to your tanks, usually that's your vent screen, your vents. Every tank is required to have some sort of a vent so it doesn't implode on itself when you start sucking the water out. Well, obviously you don't want to just have an open connection. You know, you don't want to just have an open top like that northern city where they're using it as a beautification retention pond. You know, you want to make sure you're keeping things out of it. Bugs, birds, people. There's certain requirements on your entry points. Like all your access manways must be secured when not being used. If you have hatches, they must be locked whenever you're not actively entering or exiting a tank. And then, again, this is for Texas. I believe it's the same for Louisiana, but I won't swear to it. You must have 200 gallons of capacity of storage per person. Anybody know if that's the same here? Okay. Well, for Texas, that is a requirement we have. Now, one of the things for City of Houston we tried to do, we thought we were going to be smooth. We had some old tanks that needed to be replaced. You know, we're always looking for ways to save money. We said, well, we've got a lot of really big distribution lines out there. You know, we've got lines up to 96 inches in our system. But we thought, well, you know, we got a mile of 96-inch pipe. That holds as much water as a whole storage tank. We petitioned to the state. We said, well, can we get credit for our storage capacity by using our distribution system? They laughed at us. They said, if it's not inside the fence, you can't count it as storage. No, they said once it leaves the original fence, they won't count it anymore. Like I said, we were trying to save a little bit of money. We at least had to try. Yeah, it is storage. I mean, we actually added up a while back. We were doing some sort of a presentation for a school or something. So we're looking for some interesting facts to find out, you know, fun facts that we could tell the kids. We calculated up if we took all of our water just in our distribution system at any given time, that we could fill the Astrodome up 2.5 times. Now, I don't remember the number of gallons, but you know, it shows even in a smaller system, you've got a lot of storage sitting out in there. You know, I think 8-inch pipe, you got about 2.5 gallons a foot. So if you've got, you know, a mile of 8-inch pipe, you still got several thousand gallons of water sitting out there. But, you know, in an emergency situation like a fire, you can quickly deplete that. So you got to make sure you have adequate storage. Now, this is just an example of a storage tank. You know, you'll see all sizes, shapes, materials. You know, what's most common around here? Galvanized, steel, any concrete? Mostly elevated? For ground storage? Okay, well, we're going to talk about elevators coming up next. Thank you. We went through a phase where we had a director who, he became obsessed with concrete tanks. He thought they're the greatest thing since chlorine. I think he had, you know, somebody related to him that sold concrete tanks. I'm just joking, I didn't say that. But we found out that no matter what they did, no matter how well they were built, within a year or two, they all leaked. You know, for our particular situation, our ground shifts too much, every one of them end up leaking. Yeah, they're less maintenance in the long run as far as painting and coating, but they're a headache. You go around the ground on any concrete tank, they're all saturated. We actually, where my office is, yeah. Well, actually, where my office is right now, it's one of our old, it's an old facility, but it's no longer an active plant. It's just basically an office building at this point. We have a 8 million gallon semi-underground tank. It was submerged about halfway in the ground, and then they built a big hill over it because it's right outside downtown. They didn't want this big tank just sticking out there. Well, we're going through right now, you know, we have Buffalo Bio runs right through the center of the city, and they've got this big beautification project going on, and they've decided they want to build something in that tank because it's right next to the bio, and they've decided we don't know what we're gonna build in it, but they've built a fence around it and said we're gonna put something in that tank. We don't like it because it took away about half our parking. Now on your storage tanks, you have to have some sort of access to get in them because although we normally want to keep things out of the tank, periodically you are going to have to get in there to do maintenance. You know, you're going to have to go in and inspect, you're going to have to go in and fix something. You're supposed to have some sort of an access at least 30 inches. It's intended that way you have enough room to get in there with a piece of equipment. Now if you have an older tank that does not have a 30-inch access, you may be required to provide it during maintenance. So on the chance that you do have less than a 30-inch opening, when you go ahead and cut that opening for maintenance, put a hatch there, that way you don't have to keep cutting it each time you go in there. All your coatings on your tanks have to be approved by AWWA standards, which the AWWA standards will tell you go to the NSF standards. You know, it's just like, I see it all the time. You can get lost in a maze. You'll say, well, what's the standard on this? You think, well, DHH regulates this. Let me go to our sanitary code. Sanitary code, right? Okay. We call ours water code. But we have a bunch of separate codes. Well, you go to the sanitary code and it says, refer to AWWA standard. You go to AWWA standard, refer to the NSF standard. And I believe on coatings, that's where it stops. Absolutely no kind of lead products are allowed inside the tanks because where does your water spend a good portion of its life? Sitting in that tank. Lead leaches, that's why we have the lead and copper rule. So absolutely no type of lead-based paints, lead fittings, lead solder, anything like that can be used inside a tank. Shouldn't be used on the outside either, but I think they're a little more lenient on that. But if you ever have to repaint, they're going to have you replace it with non-lead based paint. And like I said, all your coatings have to be approved. You can't say, well, I've got some leftover paint when I painted some fire hydrants, or, you know, Carl's got a 5-gallon bucket of paint left over from when he painted his house. I'm gonna just paint my tank with that. It's gotta be approved paints. You know, like I said, it's basically steadily being in contact with your water, so it's got to be able to withstand that water and not contaminate it. There, that's what y'all said. Y'all are all about the elevated tanks here. So you know they take all shapes, sizes, forms. That one look just like yours? I wonder why they would do that. I've actually got one that looks pretty much exactly like that, except we don't put anything on ours. We just paint them. We don't want people to know who they belong to. No, we put our label at the fence. We don't put it up on the tank. Now, I have seen a lot of the elevated tanks, a lot of cities that use them as their landmark, their distinguishing feature. I know in Texas we've got one that's painted like a golf ball. They've painted the stem like a T and the bowl is the ball. I've seen one painted as a fish tank with a big goldfish painted on the side. And for some reason, I still haven't figured out, there's one, it's painted hot pink. I guess they want to be known as the city with the hot pink water tower. You come down the highway, you can't miss them. Like I said, you talked about you got a lot of hills here. Well, by having that height, that helps to maintain your pressure. This was a test question earlier. I'm assuming since y'all have so many elevated towers, everyone got this right. Or did you say, or were you looking for 0.23 or 2.31? And again, this is a Texas requirement, so it may be slightly different here in Louisiana, but it's going to be very close. If your system has at least 2,500 connections, it's required. Now you may use it otherwise. You may have a system of only 1,000 and for design purposes, choose to use it. But if you have at least 2,500 connections, they will require you to have one, at least one. They have to meet the same criteria as a ground storage tank, because all it is, it's a ground storage tank up on top of a pipe. As we were correct the very first day we were here in Louisiana, it's to help you maintain your 15 minimum PSI. Texas, we have a requirement of 20, and we were jumped on by several people saying, no, we don't have to have 20. We have to maintain at least 15, so. There you go. I see we added something since yesterday, because there was some debate in the class yesterday about, well, where does it say that we have to have 15? State Sanitary Code, section 35-D, if anybody wants to look it up. We had a guy in class yesterday, he argued up and down that he's always heard that, but it's not in the code. It's nowhere in the code. Well, apparently we found it. It is in the code. Standpipe. I said, this is something I haven't personally dealt with before, but I believe y'all have several of these here also. Basically, it's a cross between an elevated tank and a ground storage tank. It's just a really tall, skinny ground storage tank is all it is. They're always greater in height than they are in width. If it's at least 80.85, basically if it's 81 feet or taller, it's classified as elevated storage and can be used to meet that requirement of having at least one elevated tower in your system. And you usually build these up on your higher ground to take advantage of that natural increase of pressure by sitting up top. They also have to meet all the elevated storage requirements. Since it's a cross between ground storage and elevated storage, they got to meet the requirements of both. Now that horizontal looking thing down there that looks like a propane tank up on blocks, that is a pressure tank. Who here uses pressure tanks in their system? See one. These are usually found in your smaller systems. What they are, they're a hydropneumatic tank. What that basically means is you have both water and air pumped into the same tank. They're cylindrical, usually look like a big propane tank laying on its side. You fill them partially with water. You have some sort of an air compressor, something to put air in the tank. You pump a certain amount of air on top, and it acts like a shock absorber and just keeps that steady pressure on your system. What size pressure tanks do you have in your system? Is that pretty common in your system? Okay. Say it again. You have more of them than I do. Could you help answer that question? Now, I mean, I know when we have a couple in our system in Houston, but we've pretty much eliminated them because they're maintenance nightmares. And we have enough other elevateds and stuff that we were able to petition to the state and take them out of our system. But the couple we still do have, they do have filters on the air compressors. But as far as anything additional to that, I guess that really hadn't been I guess that's not really a big concern since like your ground storage tank, you have a vent, so you still have atmospheric air going into there. But particularly if you have like a gas powered one, I could see some concern there. You might be sucking exhaust, putting it in that water. All right, any type of storage you have, whether it's elevated, standpipes, ground storage tank, clear well, tanks, pressure tanks, whatever you want to call them, they should be inspected annually. Now, whether or not your state requires it, that varies from state to state. But even if you don't have a state mandate to do that inspection every year, it's still good practice. Because by doing it every year, you can find out if there's a problem, catch it before it gets out of hand. When you're doing that inspection, you should be looking at both the interior, exterior. You're trying to make sure that it's meeting all your AWWA standards, things like coating, screens, secured hatches, secured access manways. You should have some sort of corrosion protection on your system. Almost everything we have out there, unless it's a concrete tank, is built out of some kind of metal. Just about every kind of metal out there is going to deteriorate with time. And depending on what you have, you're going to have some kind of corrosion protection. Now, that corrosion protection can be paint, some sort of a coating like galvanized. Do y'all still use a lot of galvanized tanks around here? Yeah. We went through it for a while where we actually had a lot of galvanized tanks. We started having a lot of problems with them as they got older. But I actually have 2 brand new galvanized tanks that were built this year because they looked at the long-term projection for that facility and said within 20 years it's going to be phased out. We should be able to get at least 20 years. We don't want to build a 50-year tank for a plant we plan on demoing in 10 to 15 years. Ownership signs. Now in Texas, we have to have ownership signs at any kind of a water facility, whether it's a well, a plant, anything, have to have on there the name of the facility, the physical address, who owns it, a phone number to get in touch with them. Now I understand here it's not a requirement, but it's still a good practice. Because what happens if you got a neighbor down the street, maybe you got one operator and he's running to 3 different plants. But what happens if something happens in between his runs to those plants? You got a neighbor down the street drives by, they see that your tank is overflowing, maybe your limit switch failed or something, and your well's just running, and you just got water pumping out onto the ground. Well, having that sign with a contact number will allow them to contact somebody, at least gives you a better chance of somebody calling you up and saying, hey, there's a problem. Now, just like with everything, there's a flip side to it. It gives the number to that crazy neighbor who's mad about you having your plant right there. Even though that plant was there when they bought the house next door to the plant, they're now mad that that plant's there. Because at the time, when the realtor made sure to bring them when that well wasn't running, showed them the house. Well, now they've moved in, and that well kicks on at night and wakes them up. Now they're pissed off at you. But that's the nature of our business, right? Groundskeeping. This is kind of a sensitive subject for me because we went through a phase at the city where we had a director whose quote was, we are in the business of making water, not cutting grass. Slashed our groundskeeping budget to virtually nothing. Well, a lot of people, to her bosses, it sounded good. Like, yeah, what? We're spending millions of dollars a year cutting grass. We could use that money somewhere else. Why are we cutting grass? It creates safety hazards. It looks bad. And it goes a long way towards your public perception. Because the public looks at your facility, they drive by, they see high grass, they see paint peeling off, they see junk in the yard. What do they assume? Exactly. They look at the facility and they say, man, these guys can't even cut the grass. You think I'm gonna trust them with water? If they can't manage to paint their tanks, you think I'm gonna trust to drink the water they're producing? Because they obviously don't know what they're doing. You could have the best water quality in the state. You could have the best water quality in the world. But if your plant looks bad, the public assumes that it's bad. Also, state people. That's one of the things I have my guys do whenever we have a state inspection coming up. We go through, we clean everything. We wipe down the pumps, we pressure wash the walls, we make everything look nice and pretty. They walk in, yeah, man, this plant looks clean. Yeah, okay, everything looks good here. They suddenly get a lot more forgiving. But they walk in, they see a bunch of cobwebs, dirt, you know, where you spilled some oil while you were topping off your bearings or something. They assume if you're not cleaning up, you're not taking care of business. Groundskeeping and housekeeping are a major, you know, it goes a long ways in giving you a good reputation with both the public and regulators. Plus, who wants to go in and have to go check a sample tap that's an 8-foot tall grass? The way I look at it is, if I personally wouldn't want to do it, I know my operators wouldn't want to do it. I'm not going to subject them to something I wouldn't do myself. You look like you got a question or a doubt. No, right here, Carl. Yeah.
Yeah, I was just saying that. But there's a flip side there, because I always think of it as I'm getting to show little of the substance. You know, it may look good, but really good. Once you get into the hood crews, people run it, you're that right. Having it look nice and neat doesn't go a long way.
Yeah. Like I said, a lot of this is, you know, you want to keep the confidence and the satisfaction of your customer. You know, at the end of the day, both the state regulators, the public, everybody's our end customer. We're there, you know, to make sure that they're happy with the water we're producing. A lot of times by having a good looking plant, they're more forgiving if you do make a little error. Now, like we said, it's not all about just looking good. It's also about, you know, having good quality. A big part of that is making sure that everything is sanitary. When you put that water in the tank, that's why we don't use ozone very much. Or if you use ozone, you still got to add chlorine, because that ozone doesn't leave that residual. It doesn't give you that insurance that nothing's going to start growing after the fact. Anytime you have water stored in anything, a tank, elevated tank, pressure tank, any of those, make sure you have the adequate disinfection residual. I was talking to somebody yesterday, asking them, what's your minimum residual you have to have in your tanks here? Or do you have a minimum in your tank? It's just minimum at the end of the system? Okay. The way we do ours is we have a, they calculate the average detention time for each tank, and then based off of that, you get credit for what the minimum residual you have to have in that tank is. So like we said, it's a combination of time plus strength determines your effectiveness of your disinfection. If you do have any underground tanks, which I don't think anybody here has any underground tanks, do you? I think those have pretty much been eliminated, gone out of favor. But if you do, you know, be aware of where you're putting them. You obviously don't want to put them, you know, right next to the septic system drain field or anything. If you do find any kind of cracks or leaks on any of your tanks, not only are you losing water, but you're creating a potential access point for contamination, you know, any kind of dirt, debris, bacteria, any kind of contamination can get in through that, even the smallest crack. Actively try to prevent any kind of contamination getting in the system through any method other than the cracks or leaks. At any point you have to take that tank out of service, drain it, you know, or just open it up to go inside it. Make sure you're disinfecting it afterwards. You know, and again, look to your sanitary code, and it should have the minimum residuals of what you have to put in that tank after you do drain. Anybody know what the minimum is? Most states, it'll vary somewhere 25, 50 parts. Like I said, but look to your sanitary code here for specifics. Now, once we produce the water, how do we get it out to the customer? You know, it goes to the distribution system. Distribution system consists of mains, service lines, meters, valves, hydrants, pump stations. Now, I had somebody ask me, what is a pump station? Well, a pump station is basically anywhere, like if you have, maybe you have a very long system, you know, well, you can't, obviously you don't want to put water out of the plant at 100 PSI, in order to keep, 15 at the very end of the line. So what you might do is you build a repump station in the center somewhere. You're pumping it from one plant to the next, where you have no treatment process or anything. All you're doing is repressurizing that water, helping to make it all the way to the end of the line. For the city of Houston, we've got 8 repump stations. Like I said, I think our distribution, well, we have about 650 square miles of city with 7,500 miles of pipe. So it takes a little repumping to get the water to some locations, because all our big plants are built on the east side of town where the water's at, and all the construction is going on the west side of town. They never want to build close to the water. They want you to get the water to them, though. Like I said, just like with anything else you put in your system, it's got to meet the applicable state standards. Again, look to your sanitary code for specific requirements on, types of pipe, materials, all of that. Make sure you maintain that 15 PSI at all times, because what happens if you let it go below 15? Boil water notice. What happens when you have boil water notice? Yes. You could have a perfect record for 20 years. You let one person get sick in your system and it gets proven, or even if it's not proven, but people start saying it came from the water, that 20 years of goodwill just went out the window. And once you get out in your distribution system, pipes can take all sizes, shapes, well, not necessarily shapes, but all sizes, all types of material. Some of the common ones: ductile iron, cast iron, steel, concrete. You'll find in this business we go through cycles where at one time, ductile iron was the popular pipe, then steel pipe. Concrete, the asbestos concrete was real big in the 70s and early 80s. Now nobody will touch the stuff. Still get some concrete reinforced pipe, but you don't see the AC pipe anymore. What do we go to now? PVC. Almost everything gone in the ground in the past 20 years is probably PVC. Now when you get into some of your large stuff, I say large, generally if you go above a 16 or up, most time you're not going to see PVC. It is out there. I have seen a 30-inch PVC line in a system, but when it gets that big, they're not AWWA approved, so most systems will not use them. Plus, I'm sure in another, 15 years, within the next 15 years, there'll be somebody will come out and say that the PVC pipe is somehow bad for us, that it's leaching off contaminants, it's causing cancer or something, and then we'll do a 180 and we'll stop using any PVC. But for right now, it's cheap, it's easy to work with, it's semi-flexible, it doesn't break as much. Y'all have a big problem with the ground shifting around here? Yeah. Houston, we have a really bad problem with ground shifting. We're on a very clay soil that expands and contracts when it dries and gets wet. Well, when it gets dry in the summertime, our ground shifts. Well, we don't just pull joints apart, we snap them in half. 2 years ago, we went through a drought. We were averaging a backlog of about 1,200 leaks a day. That was our backlog. We had, I think we've got about roughly 500 people in our maintenance group that's all they do is repair leaks. We still had to bring in contractors to handle over half of the work. So finding the right pipe for the right job will go a long way to making sure you reduce that. Because a lot of the areas where we were having the breaks, all that old AC pipe, it's not forgiving. Any little shift and that stuff crumbles. Now, depending on the type of pipe you have, you'll have different types of pipe joints. Obviously, your steel is going to be welded, but just about anything other than that, you're going to have a bell and spigot type setup, basically a male, female, with a gasket in there. You push it in. All that holds that pipe together is the pressure from the ground around it. You know, in order to decide what kind of material you're going to use, you have to take into consideration the joints of what that particular application is going to be. This is something that just recently changed. I believe September 1st it changed. In the past, you could use up to 8% lead in your solder or any of your flux, anything you're using to make those connections. I believe September 1st, it just went into effect. 0.025 is the maximum lead content. Now, we were told yesterday that that the state is allowing you, if you have any stock on hand, as long as you use it up before the end of the calendar year, that they'll allow you to use it so you don't have to just throw it out. But if you've bought it in the last year, it's probably lead-free at this point. You know, the industry sees this stuff coming way before we do, and they start gearing up. Usually the municipalities and operating companies, we're usually the last ones to find out about this stuff. Everybody knows before we do. Now, the next major component of your system are valves. Anybody know what kind of valve that is up there? Hydraulic valve? What'd you say? That's it right there. Now, depending on the application, the same valve will be called two different things. You put that on an elevated tower to control the flow as it goes into the tower. You set it where you want it to open at a certain pressure. It's called an out-tube valve. That same valve, you put it out in your system, you want to control how much pressure you're putting out. Like we use them for areas where you're very close to a large plant. You know, we start out with 75 or 80, but we obviously don't want 80 pounds going to the customer's house. So for the smaller lines coming off that, we'll put these on there. You can regulate your pressure down. We call them pressure reducing valve. But it's the exact same valve, it just depends on where you put it. Just like a clear well versus a ground storage tank, same thing, two different applications, call it two different things. But your most common valve you're going to find out in your system, isolation valves. All that is a valve you put there so you can shut off a section line if you ever have to take it out of service, do a repair, anything. That way you don't have to shut your whole system down. Most of those valves will be a gate valve. Who knows the difference between a gate valve and a butterfly valve? Sometimes. But yeah. What's the rule of thumb for a gate valve to figure out what size it is? Yeah, but what's the rule of thumb for the count? How many? You know how to tell what size valve? For what size?
17 to 19 turns to closure and open.
But for what size? 3 times the size plus 2 turns will tell you how big a gate valve is. 95% of the time. Now, when you get into some of your larger gate valves, I found a 20-inch gate valve once had 360 turns on it. I swore up and down that thing was broken. I said, "There's no way this thing is." I found the contractor who put the line in, and I asked him. He said, "Hey, that's what they told us to put in at the time. I don't know why, but." So it's not 100%, but if you're ever out there and you find a valve and you're trying to figure out what size it is, maybe you got 2 lines that are close together and you're trying to figure out which one it is, 3 times plus 2 will give you, generally it'll get you real close to what size the valve is. Like an 8-inch valve, 26, 27 turns. 6-inch, usually 18 to 20 turns. But butterfly, it all depends on what gear it is. Now, kind of got off the subject there, but gate valve, basically you have a disc moves up and down. Butterfly, side to side. Biggest difference. And again, that may vary by your state. We do have some. We try to avoid them, except for large ones. For some of our very large valves, okay. Like I said, as a general rule, we try not to put them out in the system, except for large valves. Anything over, usually anything over 20-inch, we put a butterfly. Just for the fact that if you ever tried to open a really large gate valve, when you've dewatered one side of it, you'll shear the pin off, you'll break the nut off, and usually if we have a really large gate valve, we'll put a small bypass to go around it. That way we can fill the other side of the line up, equalize the pressure, and then open it up. Then you got all kinds of controlling valves, pressure regulating valves, flow directional valves. What's a flow direction valve? You got it. What's the purpose of that check valve? Yep. All of that is, it's a valve that lets the water go one way, won't let it go back the other way. Kind of like the old Roach Motel. They check in, but they can't check out. That way, if you got, like particularly on your booster pumps, even if you're not required to have a check valve on your booster pump, which you are required to have a check valve on your booster pumps, correct? Okay. Like I said, that varies from state to state. Why it wouldn't be a requirement, I don't know, but that way, when that pump's not running, it keeps that water from the distribution system from coming back into your plant. Then you got globe valves, diaphragm valves, rotary valves. There's all different kinds, but the ones you're going to see the most, your gate valves and your butterfly valves. And the fire hydrant. That's one of the most visible components of our system. It's also can be the source of many arguments between the fire department and the water department. Because the fire department will claim them as long as it's in their interest, but when it comes time to spend money on them or fix them, what do they say? Oh, that's your fire hydrant. That's not mine. Well, obviously their primary purpose, put out fires. That's why it's called a fire hydrant. But they also serve a lot of purposes for the distribution system. It's your best source, or it's your best location you can flush your lines out. Like I said, nothing gets the flow going like a 4.5 on a fire hydrant. You can also use it if you have a problem out in your system. It's a good way to track down your problem. Because they slam them shut, right? We can usually tell when we suddenly get a rash of complaints in the neighborhood, we know fire department's out doing their checks. Because they'll spin them open, they get some water, they slam it back shut, they stir the rust and stuff up in the lines. They don't care. They don't have to answer the complaints. All they care is that it worked. Also, if you do any kind of construction, make a repair, it's a good place to bleed off the air out of the line. That way you don't have to install a bunch of blow-offs, particularly if you're going to install a blow-off just to bleed the line out. If you got a fire hydrant, just use the fire hydrant. Don't ever try to chlorinate a line through a fire hydrant. Too much brass in there. Now this is something that's fairly new, automatic flushers. Anybody here have any automatic flushers in their system? All right. Want to tell me what you use it for? HydroGuard? Okay. Yep. Yeah. Basically, all an auto flusher is just what it sounds like. It's something that automatically flushes your line for you. You got an area where you got low residual, you're not getting good flow, you may be having some water quality problems. You set this up, all it is, it's a little electronic valve. They come in many different sizes. Like this one here, it's a portable one that you can put on a fire hydrant. We actually recently purchased a bunch of those. Now, the biggest problem we have is the fire department goes out and shuts them off because they don't know what it is, even though it's got a big sticker on the side that says, "Property of City of Houston, please call this number before turning off." They can't be bothered with that. They just know somebody's put something on their fire hydrant and got a chain around it. Like I said, these are real good for maintaining water quality. Generally, the valves on them are fairly small. They don't get the velocity of a normal flush. So you want to do a preliminary flush and get the water quality up to where you want it to be, and then use this to maintain it. Like I said, we were buying a lot of these at one point. We got to looking at what the components in them were, figured out we could build them a whole lot cheaper. They're basically irrigation supplies. Sprinkler systems is all they are. But if you got a local vendor selling them to you and you like them, you can ignore that I said that. Otherwise, go to your local sprinkler supply place and you can build your own a whole lot cheaper. Water meters. What's our number one job here in this business? That's the real answer. Now, yes, it's to serve the public, provide good water, but ultimately, what does the city council, the mayor, what do the financial people care about? Making money, collecting that revenue. Because we're not making water just because we're nice guys and a nice lady. We're doing it because obviously the public needs it, but the city or whoever you work with, they want to get paid for that water. They don't want to just give it away. How do we do that? Unless you're going to work on a flat rate system, which I understand there are still some municipalities here doing a flat rate, but that's pretty uncommon nowadays. Generally, you're going to have some sort of a meter to account for the water that people are using. It measures the flow, tells you how much is going through where. They come in all different kinds. You got propeller, compound, positive displacement. A propeller meter, pretty much what it sounds like. It's got a little disc inside and it spins, turns a wheel, pretty much like the odometer on your car. Now the magnetic meter actually it measures the flow without actually physically touching the water. Don't get me lying on the specifics of how it works, but it involves magnets and it measures the electrical difference between them or something, tells them how fast the water's flowing through there and can tell them how much water it is. Now you got a compound meter. The propeller meters are generally your small meters. Your magnetic meters are usually your much larger ones, 8-inch, 12-inch. Sometimes you have a situation where you have a customer periodically uses a lot of water, like some sort of a processing plant where they use a ton of water at one time. They have a big tank they fill up 2 times a day. So during that time, they're sucking in 10,000 gallons a minute. But the rest of the day, they're only using, they're running the water fountains and running the bathrooms. Well, a compound meter can measure both ways. That way, during high flows, it can capture that, and then during low flows, you're not just giving away water. Most of your residential meters are a positive displacement type. Like I said, that's generally where most of your utilities income comes from. Because for most cities, except here in Louisiana where your police department writing tickets is the #1 source of revenue, your water department is usually one of your biggest money makers in the city. I've seen enough of those speed traps we've driven through here. I told people I was coming this direction. They said, when you go through Alexandria, they said, watch out as soon as you hit the city limits. They said, cop will sit right there. And he said, he'll sit right in front of the speed limit sign because the speed limit changes. He goes, you'll be going along. He'll pull you over. You tell him, but the speed limit says 55. Yeah, it's 55 after that sign. It's 35 right here. Huh? Oh, yeah. We have our share of them, too.
Who's the victim on a broken water meter? That's again discussion. Customer complains, my water is broken. That's out, they are the beneficiaries of a broken water. Because the meter's not correct.
Now, if it's depending on how it's broken.
Yeah, it is.
Yeah.
Well,
Well, now if you have one where it's reading higher than it should, that's usually on your larger meters. You see that because your direct read meters, that's pretty unusual. But I actually have seen on some of the small residential meters, there's a small little disc in there And I have seen where that wears and it'll spin faster than it's supposed to. Now in that case, customer's gonna be very unhappy with you. But if it's broken in their favor, where it's not reading, obviously they're benefiting from it.
We had complaints like that. Came out, asked someone to come out and survey our water. He took the representative, screwed out that. And the average meter was registered only 82 to 86% efficiency.
Wow.
A lot of them were older meters. So the customer complained, we go, we're gonna do meter, put it in. Next month, they want to be, goes up, increase. No, I need no more. Well, okay, you asked us for a new meter. That meter is registered 100% on water usage. Now, that old meter you had, they were only registered about 82 to 86%.
Then they say, well, bring that old meter back. Like we said earlier, be careful what you wish for. All right, now, how do all these pipes get into the ground out there? They all magically appeared one day, right? Or for most of us, we inherited a bunch of old pipes we don't want? Well, periodically you're gonna have to put in new pipes. One big factor to consider when you're putting in pipes, and I know we probably don't design it usually, it's usually handed off to us to either get a contractor to put it in or to put it in, but we're told where to put it. Make sure that there's an adequate separation between the water line and any source of contamination. The big one is sewer lines. Here in Louisiana, what's the minimum requirements between the lines? I heard 6 feet and 18 inches. 6 feet what direction? "18 inches vertical. Texas, ours is a little bit more strict. We have a 9 foot between, but it's the same 18 inch. Now, say you have to have two lines crossing each other. You've got that 18 inch difference. Does it matter where, as long as they're 18 inches apart? Why? Exactly. Because if that sewer line leaks, where's it going? Down. Well, unless you got something down here and it's, starts bubbling to the top, but 95% of the time, it's going straight down. You got it crossing over the top of your water line, you got a bad joint, you lose pressure, something, you're back to who was it that tied the lines together? You'll be known as the next Pineville. I'm sure Pineville probably gets sick of hearing about that story, don't they? We had a couple people from Pineville yesterday. We sure didn't hear that story in there yesterday. They were real quiet. I wonder why. I will say, I won't say it hasn't happened, but not that I know of. We haven't tied any sewer to water lines, but we have tapped a customer into our well line on accident before. Couldn't figure out why that their pressure was real low. They said, well, a few times a day my pressure will be all right. They said, but most of the time, pressure sucks. We couldn't figure it out. We're like, it was a brand new business. Went out there, started looking around, like, we saw where their meter is. I'm like, we don't have a water line on this side of the street. Went back, looked down the street. There's a well down there. When the well would come on, they'd get pressure. The rest of the time, it was a bottom filled tank. They were getting at about 8 pounds of PSI coming off the tank. So accidents happen, even with the best of care, best of intentions, stuff will happen. Now, whenever you do when you put in a new pipe, be aware of what you're putting back over the top of your pipe. Don't necessarily just put back, well, this is the dirt that came out, so I'm putting it back in. Make sure it's in good condition, that it's clean, solid backfill. Because if you pulled out a bunch of rocks, you're not going to get a good, even cover. You might need to bring in some clean backfill dirt. You're supposed to have at least 24 inches of cover. Now, I know sometimes something might put in 24 inches below the ground, and over time, erosion, people building things. Next thing you know, you've got a line 6 inch underground. But anything new, at least 24 inches. Anytime you're working inside a trench, you have to have some kind of protection to protect you from cave-ins if you have at least, 5 feet deep. Now, is 5 feet an absolute? I see a bunch of heads shaking out. What other factors might influence you need to put in cave-in protection for that? Type of soil, weather conditions. True. That's one that a lot of people overlook. If you're digging real close to roadway, you know, all that vibration from traffic coming by, you might want, while you may not be required to put it in, at the end of the day, it'll save everybody a bunch of headache and possible injuries if you just go ahead and put some sort of cave-in protection. Exactly. I mean, because most time, unless we're putting in something brand new, why are we digging? Something's broken and leaking. Now, shoring, that's basically a use of any kind of a sheet of wood, metal, something to brace the walls with braces in between. Now, what most people are going to is rather than building shoring on site, you're getting pre-engineered trench boxes. Benefit of that, they're pre-engineered, they're pre-approved, because if you have if you build shoring on site, depending on your state regulations, you may have to have an engineer come out and approve that shoring every time you do it. And I don't know about you, but I don't want to have to call out an engineer every time I want to dig a hole. I could buy this pre-engineered trench box, drop it in the hole, and it's approved. So somebody back there said sloping earlier. Sloping is pretty much what it sounds like. Rather than digging a hole straight down the width you need it, you come in at an angle, reduces the likelihood of caving in. Now, this is favored a lot of times if you're in a nice open area where you have room to dig a real wide hole, because then you don't have to have a trench box, any kind of shoring. Drawback is, most time we're not digging in a nice open area. You generally have to have your hole twice as wide as it is deep in order to use to use sloping. So if you got to dig a 12-foot deep trench to get to that pipe, there's not too many locations you're going to have 24 feet wide to dig that trench. Said earlier, 2 feet away from, minimum 2 feet away from the edge of your hole for all spoil. Your pipe bedding, just like with your cover material, you want to make sure that you put a nice even bed of good material underneath that pipe. That way you have nice even support all the way across. This top picture up here, that shows what your bedding should look like before you put that pipe in. Go back with at least 4 inches of some kind of clean bedding material. Most people will use crushed gravel, stabilized sand. I like stabilized sand because once you put it in there, it's easy to work with. You tamp it down, you wet it. It's hard as concrete after that. It doesn't move. But whatever works for you, whatever meets your state's requirements. Also,
It's the most stabilized for land that's going to possibly shift. Compact.
yeah, and that's the thing. Don't just dump the dirt in there, set your pipe on top, think you're good to go. Go in there and pack it down because that stuff will, it'll settle with time. You want to settle it before you put that pipe in there on top of it because you get all those gaps, you're creating stress points on that pipe. It's another chance for that joint to come apart or that pipe to snap on you. Pipe bracing. Who knows what the purpose of bracing a pipe is? Exactly. Yeah, remember, think about that water traveling through that pipe. It's like an 18-wheeler hauling down the road, going straight. You suddenly get to a 90-degree turn. Well, if that water doesn't slow down, or that 18-wheeler doesn't slow down, he's going to go straight off the end of the road, right? Well, there's no brakes on the water. There's no way to slow it down. So you got to put something into that pipe so that water doesn't just blow straight through. I've seen a lot of lines blow out because of poor blocking. We actually had a contractor killed in Houston about 3 years ago, I guess. They were working on a 36-inch pipe. Contractor dug out the thrust block to weld up a joint that was leaking. Well, after they got done, they told the welder, stay down in the hole while we bring the water on so we can make sure that your weld held. Well, they violated a whole bunch of safety rules right there. That water hit that 90-degree turn. It blew the pipe apart. That guy didn't make it home to his family that night because that contractor had dug that thrust block out. There was nothing holding that pipe together. And nobody on the job site stopped to think, well, this big pile of concrete was here for some reason. You know. Now, when you're putting in pipes, doing any kind of repairs, just like with your tanks, you want to keep in mind the sanitation. You want to keep it clean, because we know we only work in nice, clean, dry pits, right? I don't get wet when I go to work. I don't get muddy. At least I don't. My guys do. But in the real world, we know you can't always keep a pit dry. You can't keep it clean. But put forth the effort to keep it as clean and dry as you can. You got to try to keep that trench water out of that pipe, because that trench water is some nasty stuff. Because you don't know what was in that dirt that water just ran through. You don't know what's been washed off the road. You don't know you don't know what's in that water going into that pipe. It's a lot easier to keep it out than it is to get it out once it gets in. As you're putting your pipe in, swab everything with a bleach solution. What I tell my contractors to do, take a 1-gallon jug of household bleach. Household bleach is generally about 5%. Notice some of the newer stuff for the high efficiency washing machines, they're up in the concentrations, but still it'll work. Get a gallon of household bleach, put it in a 5-gallon bucket, top it off with water. That'll give you about a 1% solution. That's what AWWA recommends for any type of swabbing. But also make sure you tell them, use a clean rag. Don't go find some dirty rag that's been riding around in their toolbox. You know, take out a nice clean rag, or if they've got to get up in a pipe, have them purchase a new disposable mop. Something clean that they can make sure they apply that solution to. Anytime you're going to go on break, you're going to call it a day. You're laying several joints of pipe, you don't finish it at the end of the day. Put something over the end of it. The correct thing to do is put a pipe cap over the end. I know we don't always have a pipe cap available. At the very least, and again, this is the bare minimum, take some plastic, a trash bag, tape it around, just something to keep debris, animals, deter things from getting into that pipe. Because what happens, you leave a pipe open overnight down in the trench, that possum, raccoon, squirrel, neighborhood kid, somebody says, oh, I see an open, I'm gonna climb in here. Next morning you show up, you get back to work, next thing you know, you got something trapped inside that line. I've seen, at one point I was over a crew that we would actually inspect large diameter lines, the interiors of them. You name it, I've seen it inside a pipe. I found hard hats, buckets, tools, clothes, baseball. The one that blew my mind the most is found some bicycle parts in a pipe. How they got there, I'll never know. Probably somebody either had a bike they wanted to get rid of for some reason, saw an open pipe, chunked it in there, the workers putting the pipe together the next day, just whether they saw it, maybe the worker put it in there. They were mad at their boss for something. They thought it'd be funny. They would say, let's see what we can get inside this pipe. At baseball, they were repairing a line right across the street from a park, left the hole open during the night. Somebody hit a fly ball, went in the pipe. The way we found it is we were trying to blow the line off. We had a 2-inch blow off, and it'd run for a minute, and all of a sudden we hear a loud pop, blow off and completely stop. We shut it off, wait a minute, open it up, it'd run again, and then it'd pop. We dug it up, had them pull the end cap off of it. There was a baseball stuck in it. So make sure you're covering up the end of that pipe at the end of the day, or even if you're just going on lunch, put something over it, because anytime that pipe is unattended, you know, there's always potential for something to get in there. Anytime you put a new piece of pipe in the ground, anything that's going to come in contact with your water, SDWA standards require that they be disinfected. They give you 3 options. Tablet, which is what most contractors and smaller municipalities will use because it's easy, cost effective. Then you have the continuous. That is where you actually set up a chlorine feed system, similar to what you'd have in your plant. And you actually feed chlorine into that pipe as the pipe is being filled till you get a desired residual at the end. Then you shut it off and do your sampling. But then you have what's called a slug method. This is only recommended during emergency situations. You've got a major line out of service, you've got a bunch of people out of water, it's got to go back in service as soon as possible. In this situation, you feed an extremely high dosage, 300 ppms into the pipe, allow it to sit for 30 minutes, flush it off, take your samples, put it back in service. But again, they only recommend that for emergency situations. And your state may not allow that. I don't know the regulation on that here. But remember, if you put 300 parts in, you're going to have to dispose of that 300 parts somewhere. In your book, table 7.1's got the details on if you want to go through all the details of that. But after you do your disinfection, regardless of which method you do, you obviously don't want to put that high dose of chlorine into your customer's house. So you flush it off, collect your samples. You know, you'll take the same samples that you would take on your monthly back tees, you take that on your construction. Like I said, we put in an average of about 100,000 feet of pipe a month in Houston, and we have to have 1 sample for every dead end and every 1,000 feet of pipe. We take in about 500-600 construction samples a month. So. Now again, depending on your state, you may have to dechlorinate that water that you're flushing out of there. Texas, we just, like last month, started being required to have to dechlorinate that water that we're flushing out. For a long time, there was some ambiguity in our regulation that we were using to our advantage, so we didn't have to dechlorinate. Well, it's been clarified now, so if you're going to have to do any kind of disinfecting on a line here, you might want to check it out before you do it. Make sure you're not in violation of your state code. The disinfection? Well, we've got a couple different methods. The low-tech way, we get burlap sacks, fill them with sodium thiosulfate, and put a barrier in front of the blow-off and let it run over the top of that. Then we actually bought a little semi-high-tech dechlorination system that looks good if you're in a high-profile area. And it feeds ascorbic acid, which is another dechlorination agent, which basically is vitamin C, because some of your dechlorination agents can be as hazardous to the environment as the chlorine itself. At one point, we tried using sodium bisulfite. Sodium bisulfite depletes your dissolved oxygen in your water. It'll cause a fish kill just as fast as dumping that chlorine in the water will. So just, if you do have to dechlorinate, be aware of your surroundings, find out what your particular situation is. There is no one-size-fits-all answer on dechlorination. Something like that. Now, to maintain your distribution system, periodically you're going to have to do flushing. There's several different kinds of flushes. We'll actually go more in depth later on. But you have dead end flushing. All your dead ends are supposed to be flushed once a month. I believe that is in your state code. Anybody know for sure? Huh? Okay. Well, like I said, but you may be required by your state to flush once a month, but there's also maintenance flushing. Like I said, you can do routine flushing to reduce slime, scale buildup, help bring up your residual, get rid of any red water complaints you might have. inside your pipe, when you have an area that has low chlorine for an extended period of time, you start getting what's called a biofilm buildup in there. It's basically a slime of bacteria growing in the pipe that'll eat up that chlorine as it goes through there. Anytime you're flushing, you want to be careful of your surroundings. You know, don't assume, well, I need to flush, so I'm just going to open it full blast and let it go. Now, ideally, to get a good scour of your pipe, you should open the fire hydrant all the way, but be aware of where you're aiming it. Use a diffuser if necessary. Don't do like one of my employees did once. Customer had parked their car right in front of the hydrant he needed to flush. He just opened it up, let it blow against the side of the car. Next thing you know, we're having to pay a claim because he's damaged their car. His attitude was, they were illegally parked. They were blocking the fire hydrant. Well, two wrongs don't make a right. And that doesn't fly when I have to, write a response to city legal saying, who's the bozo who put a dent in the side of this car with a fire hydrant? Because a full blast fire hydrant can do some damage. It'll blow you down. It'll put a dent inside of a car. It'll wash away dirt, rocks, whatever's in its way. No, I know what you're talking about. I haven't seen it. See, fire department tends to get away with a lot more stuff than we do. Now, if fire department do it, they might get away because they say it was an emergency. Flushing that dead end is not an emergency in the eyes of the city council or the mayor or legal department or the customer whose car you just dented. This is an example right here of a fire hydrant, why we have to flush sometimes. I'm sure we've all seen some water like that in our system a couple times. Y'all need a break? All right, we'll keep going then. Didn't want to lose anybody. Anybody have any idea what that is on the left-hand side of that pipe? Say it again. Tuberculation. Tuberculation is basically a buildup of scale inside your pipe. A lot of times people will confuse that with corrosion. Sometimes they'll say, well, it's buildup in the pipe. That's corrosion. Well, tuberculation is a buildup of material in your pipe, whereas corrosion is a dissolving of the material in the pipe. Both of them are going to cause you problems, but it's a matter of buildup versus taking away. Both of them will do damage to your pipe, reduce your flows. Now here's another picture of some corrosion going on inside a pipe. See how it's eating away the material? And now as that material gets dissolved and it corrodes, it may settle in the pipe and look like tuberculation, but that stuff will move along as the water flows. That tuberculation is usually on there pretty hard. It's actually a buildup. There are ways you can get it out. You can use a high pressure water jet to get it out. Pigging, which I've heard pigging's pretty popular here. We don't do a whole lot of pigging anymore. I don't know why. I guess, huh? I think that's probably why we stopped doing it. Like I said, obviously as that stuff dissolves, it can be carried in the water. So it's definitely going to affect your water quality. So what causes corrosion? There's a lot of different factors. pH, dissolved oxygen, salts, even that free chlorine, the stuff we got to put in the water. Too much of it can contribute to your corrosion. Hardness, velocity. Why would velocity cause corrosion in your pipe? Any ideas? Say it again. Well, think about it. Water is your universal solvent. Water will dissolve anything with enough time. Well, as that water passes through there fast, think about it when you pressure wash something, don't you? That's what you're doing. You're knocking the stuff off using the high velocity. High temperatures can speed it up. Alkalinity, that's supposed to say sulfate reducing bacteria. Now, how do you protect from corrosion? Obviously, we see up there coatings. What kind of coatings can you use? Phosphates? That's more of a chemical treatment. Paint. What's the purpose of painting stuff? Epoxy coatings, galvanizing. It's all ways to coat the pipe. Something to keep that bare metal from being exposed to those elements. Also, you can use anodes. Anybody here use anodes in their system? Anybody know what an anode is? Yes. Basically what an anode is, it's a piece of metal that corrodes easier than the piece of metal that you're trying to protect. In your hot water heater in your house, they put what's called a sacrificial anode. It's a piece of metal that corrodes very easily. The whole purpose of that is you have all this stuff in your water that wants to cause corrosion. But like everything else, it wants to find the easiest way to do it. You know, it's like a city employee. They're looking for the easy way out. I'm a city employee too, so that wasn't one-sided. By putting that piece of metal in there that's easy to corrode and easy to dissolve, all those factors, they attack that instead of attacking your piece of pipe. It won't prevent it completely, but it will definitely slow it down. Nothing will stop your corrosion 100%. The whole point is you're trying to slow it down, extend the life of your material as long as possible. Also, you have what's called galvanic corrosion. There's certain metals that if they come in direct contact, there's a chemical difference between them, an electrical difference between them that will cause corrosion. Things like copper against steel. You directly connect copper to steel. What are most of our service leads? Copper. You got an old steel line. There's types of connections you can use called a dielectric anode, which is just basically a special type of material for a fitting, just enough that there's not a direct connection between those two types of material. You'll usually find those again on your hot water heater, where you've got that copper line goes into your plumbing off the hot water heater. There's usually a different looking little fitting right between it. That's your dielectric anode.
Is that the same thing as when you take two pipes and you PVC or metal PVC and you lay it directly on one another, both have water pressure flowing through, they will do something like a etching or burn on one another together?
No, I'm not real familiar with that, but I think that may just have more to do with the friction, the vibration of the pipe rubbing against each other.
Yeah, it's more or less the really a burn. Really the PVC would like to burn for someone to take the tank, put a metal pipe right on top of the main, which was PVC. And over a period of time, as water going across through it, actually made it burn, almost like a burn. You can tell the PVC is like a burn. It would go to the strong.
Yeah, I'm not familiar with that, but I would think it would be something to do with the vibration of the pipes being in close contact. You know, because as that water's moving through there, even if it's just a very slight vibration, a very slight movement, you know, you chip away at it long enough, it'll leave a mark. I said back there earlier, you said add a phosphate. That's a chemical treatment. That's another way you can do it. I think a lot of systems are getting away from the chemical treatment just because cost savings. No, that's why we stopped doing it. We had did a little pilot study where we tried adding some phosphate in a certain area to see if it would reduce customer complaints from color and stuff. We found out it did work, but it was costing us about $800 per complaint it reduced. We said it's cheaper to hire somebody to go answer the complaints. You know, part of maintaining your system is repairing brakes, because we all know we're dealing with stuff that's sitting in the ground, has been out there forever, you know, questionable materials, you know, who knows when it was put in the ground by who. Even if you have something new and it's put in right conditions, you're going to have brakes. In order to take care of that, you want to make sure you have the proper equipment. Particularly for your smaller municipalities, your small systems, this could be a real challenge because you might not have a backhoe on hand. You might not have the special tools you need in order to do a larger repair. Well, what a lot of small systems are doing, they're developing cooperatives. You might get 3, 4, 5 small systems in an area. Say, all right, we're all going to pitch in together. We're going to buy the equipment. We'll store it at one facility, and it'll belong to any one of us, and we can use it as needed. But even if you're in a large municipality, getting the money allocated can be another issue. But it's important to let the people who make these financial decisions understand, go in and explain to them why we need this equipment, how important it is. When you get out there to do the repair, excavate below the pipe. Don't just dig down. Oh, I see the leak coming from the top. I'm going to go ahead and put a patch on the top. Just because it's coming out of that top doesn't necessarily mean that's where it's actually leaking from. It could be coming around that pipe. It could be coming from up the pipe. Make sure you excavate around it, enough that you can see where the leak is truly coming from. And if it's leaking, you want to dig a sump on one side. That way all that water can drain to one side. You can put some sort of a pump down there, going back to keeping that trench dry and as clean as possible. Now this is something that I say this to the guys who actually do the repair. They don't like this. Whenever possible, do your repairs hot. Do them while they're under pressure. You say, well, it seems like we want to keep it dry. We want to keep it clean. So we're going to shut the water off. That makes sense, right? What's the benefit of doing it under pressure? Exactly. If you've got a positive outflow, it's a lot harder for stuff to get back into the pipe. As long as water's running out, something's not running in. Like I said, most of the guys doing the repairs, they don't like to hear that because, I don't blame them. I don't want to be standing in a pool of water while I'm working. But like I said, for health reasons, it can save you a lot of headaches, save you some potential problems. Also reduces the chance that you have to interrupt people's services. Because, if you got a leak and they see you out there fixing it, you're the good guy, you're taking care of the problem. But you go to fix that same leak and you shut their water off, suddenly now you're the jerk who shut their water off while they were trying to take a shower. They don't care that you were trying to fix it for them. It's like the people who were complaining about their meter. They wanted a new meter, but they didn't like the end result. I say, reduces your risk of contamination, also reduces your chance of air getting in your line. Because air getting in your line, you create customer complaints, it creates quality issues, you can airlock a line. Also, if you repair it while it's under pressure, the leak is your repair is gonna hold. Because it's under real life conditions when you did the repair. What's a cross connection? All right, well, before we go any further, we're going to go ahead and take about a 5-10 minute break. Y'all look like y'all are getting tired.